Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn? In this session we are going to configure the esp32 cam with the help of Node MCU esp8266. Also we are going to use our esp32 camera for object detection with the help of TensorFlow Lite on Raspbian Buster legacy version. Okay, but before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I told you, we are going to program our esp32 cam with the help of esp8266 Node MCU. Then after we are going to use our TensorFlow Lite with Raspbian Buster legacy version for object detection. Okay, so let's just start. So for that, first you need to install the opencv and TensorFlow Lite on Raspbian Buster legacy version, the 32-bit version. Okay, so I have already created a video how to install TensorFlow Lite and opencv on Raspbian Buster legacy version. That's it. So after that, for today's session, I have created here a new repository. Okay, the repository name is esp32 cam object detection. Okay, so we are going to first clone our repository. So I will mention the link. You need to simply copy and paste the link inside the browser, then go to the code, copy the link from here, copy it, minimize the browser, and we are going to open our terminal. Okay, so first let me make here a zoom in, and zoom in, just zoom in, then clear the screen. Okay, now we are going to clone our repository. So sudo git clone and paste the link which we have copied, just hit enter. Let me make more zoom in, that's it. Okay, so we have now our repository. Now we need to simply change the owner of our repository. So sudo chown space -capital R, pi is the user, pi is the group, and then pi is the user and pi is the group, then space, then we need to mention the repository name, then which is the repository name is esp32 cam object detection. Okay, that's it. So we have successfully changed the owner for our repository. Now what we want to do, we want here our Arduino IDE software. So I have already installed the Arduino IDE software on Raspbian Buster with the help of RPi apps. In programming, as you can see, I have already here Arduino IDE. Then in accessories, I have already here Pi apps. So how to install the Pi apps? CD and our repository which we have cloned, CD esp32 cam object detection. Then we are now inside our folder, ls command, and we need to simply move our txt file on desktop. As you can see, I have already moved it. Okay, so how to move the file? Simply run the command sudo space mv space, then file name which is the txt space /home/pi/desktop, and just hit enter. It will move our txt file on desktop. As you can see, I have already moved it. Then right click, text editor, and then this is the link for installing the Pi apps on our Buster. Just copy the link, copy it, open terminal, and just paste the link and just hit enter. It will automatic install Pi apps on our Buster legacy version which I have already installed it. Okay, as you can see, the installation is complete because I have already done with Pi apps installation. Now simply we have now our Pi apps. We need to open the Pi apps from accessories, click on Pi apps, and it will open the Pi application. Okay, then go to the all apps, Arduino. It will open Arduino window. As you can see, Arduino is already installed. Simply you need to click on here on install button, and it will install Arduino IDE automatically on our Raspbian Buster legacy version. That's it. So we have now our Arduino IDE successfully installed on Buster. That's it. Now what we want to do, we want to simply first connect our esp32 camera with our esp8266 Node MCU. Okay, so simply for that, inside our folder, this is what our folder, esp32 cam, this is the pins layout for our esp32 camera. Okay, so pins which we are going to use here: 3.3 volt, GPIO 0, ground, GPIO 3 which is the RX pin, GPIO 1 which is the TX pin, and the ground pin. Okay, so now this is our connectivity, the wires, okay, wires connection. Okay, so as I mentioned, we are going to use here a ground 0, 3.3 volt, then RX, TX and the ground. Okay, and the ESP8266 pins, first we need to connect ESP8266 ground and EN means the enable pin, the pins which we want to connect with each other. Okay, as you can see, I have connect the ground pin with enable of our ESP8266. okay, so we need here female to female jumper wire cables. So connect the female to female jumper wire cables with ground and enable pin of our ESP8266. That's it. Then we need to connect our ESP32 camera 3.3 volt pin with ESP8266 3.3 volt. As you can see, the 3.3 volt. Then ESP32 camera ground pin, the last pin, ground pin which we want to connect with ESP8266 ground. As you can see, the ground. Then the ESP32 camera, the first one is the RX pin. So RX connect with RX, as you can see here, the RX pin. And the second is TX, the orange wire. So TX connect with TX. Okay, so TX connect with TX, RX connect with RX, 3.3 volt connect with 3.3 volt, then the ground connect with the ground, and the ESP8266 ground and enable which we want to connect with each other using female to female jumper wire cables. Then for enabling the programming mode, we need to connect the ESP32 GPIO 0. Okay, GPIO 0, if I open the pins, as you can see, the GPIO 0, which is the third pin, GPIO 0, which you want to connect with ground. Here also you need to use the female to female jumper wire cables. Okay, so connect the female to female jumper wire cables with GPIO 0 and the ground of ESP32 camera. Okay, after you complete the sketch uploading process inside the ESP32 camera, you need to remove these female to female jumper wire cables from ESP32 camera. Okay, so remember these things. After you completed the sketch uploading process, you need to remove GPIO 0 and the ground pin of ESP32 camera. Okay, that's it. So this is how you need to connect the ESP8266 with ESP32 camera. That's it. Now we are ready. I have connected all the wires with Node MCU ESP8266 as I mentioned. That's it. Now simple, what we want to do, we want to open our Arduino IDE. So let's just open it. Programming Arduino IDE, and as you can see, it's opening. So friends, as you can see, we have successfully opened our Arduino IDE. Here first we want to enable our board. So go to the file, preferences, and in additional board manager URLs, as you can see, I have already pasted the URL. Okay, so you need to again open the txt file from text editor, and this is the link, the first one. Just copy the link, copy it, open Arduino IDE and paste the link inside the additional board manager URLs. Okay, so let me delete and just press Ctrl plus V from our keyboard. Ctrl plus V, V for Victoria. Okay, so just copy and paste, then click on OK. Then go to the tools, boards manager, and here we are going to search for ESP32. Okay, so ESP32, just hit enter, and as you can see, the ESP32 drivers which I have already installed, so that's why it says the remove. So you need to simply click on install button and it will install the ESP32 drivers. That's it. So we have now our ESP32 board enabled with our Arduino IDE. So simply go to the tools again, board, ESP32 Arduino, and here we are going to search for ESP32 rover module. So you need to select the ESP32 rover module, select it. Again go to the tools, as you can see we have select our board, upload speed which we are going to select 115200, so select it 115200. Then the partition scheme which we are going to use here, huge app3 MB. Okay, huge app3 MB, so select it. Again go to the tools, and then port which we are going to select /dev/tty USB 0. That's it. We have installed the esp32 board drivers. Also we have select our board, we have select our port. So now what we want to do, we want to simply upload the libraries. So go to the sketch, then include library. As you can see, include library, and click on add zip library. Click on the add zip library, and then we need to go inside our repository which we have cloned, esp32 cam object detection. Okay, so select it, and inside that we have, as you can see, the zip file esp32 cam -main.zip. Select it, click on OK, and now it's basically install the libraries, means it's basically upload the folder. So if you go in file manager, arduino libraries, as you can see, we have here esp32 cam -main folder. Okay, so this is how first you need to upload the library, the zip file. Okay, so now we need to upload the sketch. Okay, so what we want to do, we want to simply close the arduino IDE, and we are going to open again our folder, and we need to go inside the arduino folder. Okay, arduino folder /home/pi arduino, again the libraries, esp32 cam main, then the examples, then the folder name is Wi-Fi cam, and inside that, as you can see, the Wi-Fi cam.ino. This is what our sketch. Right click and simply click on open. Now we have our Arduino IDE installed, so it will automatically open our .ino sketch from Arduino IDE software. As you can see, it's opening. Okay, so friends, as you can see, we have our sketch ready. Now simply we need to change here SSID. Okay, so we need to basically mention the router SSID. So opencv, and the password is freedom tech. You need to mention your router SSID and your router password. That's it. Now simply we are ready, and we need to upload our sketch. But before we upload the sketch, how I have connect the hardware, means the esp32 camera and esp8266. Also how I have connect the esp8266 with the Raspberry Pi 4. Okay, so friends, as you can see, this is what our esp32 camera, and this is what our esp8266, the node MCU. Okay, and the node MCU is basically connect with our data cable to our Raspberry Pi 4. As you can see, the Raspberry Pi 4. Okay, and the esp32 camera connect with esp8266, which I have mentioned in the diagram. Okay, so this is how you need to connect the hardware. Okay, I hope you all clear. So friends, now we are ready, and we need to simply upload the sketch. So click on upload, and it will start uploading. Okay, as you can see, it's compiling the sketch. Okay, so friends, as you can see, the sketch is uploading 12%. As you can see, it's uploading. So as you can see, it's now uploading the 63%. Okay, so friends, as you can see, the 100% completed. We have successfully upload our sketch. Okay, so friends, as you can see, we have successfully uploaded the sketch. Now what we want to do, from esp32 camera, we need to remove the GPIO 0 and the ground pin which we have connect for enabling the programming mode. Okay, so as you can see, these two female to female jumper wire cables, which we want to remove it. Okay, so friends, as you can see, I have removed those jumper wire cable, the female to female jumper wire cables. Okay, now what we want to do, if you see here, we have here a small button. Okay, as you can see, we have here, if I make like this way, this one, as you can see, we have here this reset button. We need to simply click on the reset button. Okay, so friends, as I told you, this is the button. Okay, reset button, which we want to simply push. Okay, so as you can see, I have pushed it. That's it. So friends, after pushing the reset button, you will see inside the serial monitor, you will see this kind of message. As you can see, the Wi-Fi connected, camera initialize success, and this is what the link. where we have our camera access. HTTP 192.168.40.207. This is what my IP address. In your case, of course, it will depend. So I need to mention this IP address inside the browser. Okay, so just copy it and open the browser, and HTTP .192.168.43.207, just hit enter. Then you will see this kind of example. As you can see here, we need to select the JPG image, so we are going to select 800 and 600, and as you can see, this is what basically the image. We need to simply click on refresh, and as you can see, this is the, and as you can see, the picture is basically captured by our ESP32 camera. This is the images. Okay, so it means we have successfully configured our ESP32 camera. Now we are ready, and we need to simply mention our camera link inside our Python script. Okay, so now we have all done with this. Okay, so we need to simply open our Tony Python IDE, go to the here programming Tony Python IDE, and we need to go inside the file, click on open, and we need to go inside ESP32 camera object detection and ESP32 camera test.py, click on OK, and as you can see here, we need to simply mention the link. Okay, so the link I have deleted. Okay, so we need to open again the same link, http ship colon, this is the link. Okay, just hit enter, select the resolution 800600, and we need to copy the link, this one, copy it and open our Tony Python ID, and here we need to paste that link. Simply delete this one and just paste it. Okay, so 192.168. okay, this is the IP address 192. So we need to mention the link inside the URL 192.168.43.207 into 600.jpg. That's it. So now what we want to do, we want to simply minimize the Tony Python IDE, all the things, and now what we want to do, open the terminal again, and as I mentioned, I have already installed the opencv and TensorFlow Lite. So if I run the ls command, here it is, as you can see, Raspbian legacy folder. This is what the repository for installing the opencv and TensorFlow Lite in our Raspbian Buster legacy. Okay, so of course, if you watch the video where I have mentioned how to install opencv and TensorFlow Lite, definitely you have the repository. Okay, so this is the repository. So we need to go inside the repository Raspbian legacy ls command, and as you can see, install.sh and TensorFlow Lite.sh. These two bash script for installing the opencv and TensorFlow Lite, so which I have already installed. So what we want to do, we want to go inside the examples folder. Okay, so simply cd examples ls command. Again, we need to go inside the Lite folder, or we can go from here. Okay, so let's just go from our file manager, that's really better. Okay, so Raspbian legacy, open it, examples, Lite, then again examples, and here we need to search for object detection. Okay, so object detection, this is the folder object detection, Raspberry Pi and detect.py. As you can see, the detect1.py and esp32tst.py, this is the two file which I have already pasted. So I'm going to show you, I'm going to first remove these two files because I have already copy and paste it. Okay, now again open the new file manager, and this is what our ESP32 cam object detection repository which we have just cloned. Just open it, and this is the detect.py. As you can see, simply copy and paste inside the folder /home/pi Raspbian legacy examples Lite examples object detection and Raspberry Pi. Okay, then the another, again open our ESP32 camera object detection and ESP32tst2.py, simply copy and just drag and drop inside our object detection Raspberry Pi. Okay, as you can see. So now we are ready. We need to simply open the detect.py from our Thony Python IDE. So simply what we are going to do here, Thony Python IDE open, just click on S, click on file, click on open, Pi, Raspbian legacy examples, then the lite examples. Here we need to search for object detection Raspberry Pi and detect1.py. Simply click on OK. Okay, so there is nothing to change because I have already mentioned the changes. Okay, simply we are ready and we need to simply run our detect.py script. So click on open or click on say run. So friends, as you can see, we have some error. What is the error? Okay, so the error is basically we have forget to mention the HTTP. Okay, simple, go to the file again, click on open, esp32 test.py. I forget to mention here http sheet colon. This is the link. Okay, this is the right link. So this is the way we need to mention the link. Okay, as you can see, I have forgot to mention here http. That's why it's create the error. Okay, simple, save the code. Now we are ready, and if I run the detect1.py, it will start our TensorFlow Lite object detection. And as you can see, frame is started, and I have here a video inside my mobile which I am going to show to camera, and as you can see, it's detecting the person. Okay, so let me start the video. Now video is started. Okay, as you can see, the car, person, umbrella is there also, car, person is detecting. Okay, car, motor, car. So as you can see, it's perfect working. Okay, our TensorFlow Lite model is perfect working with esp32 camera. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, check care, and bye bye.